the top. Yeah, thank you. So, what our expectations are, what we want to actually gain in this class, how we are going to use it in our day-to-day activity when we start working as manual tester or as an automation tester, and I will also explain to you career paths in this um, in software testing, in manual testing, anything to do with software testing, and also the nitty-gritties, expectations, how things are meant to be done, the processes. All these are what we are going to go through in this session. As I said earlier, is an introduction to manual testing, is an introduction to testing. So the hands-on and every other stuff will be done at internship level. So which I will be explaining to you as we write them. But for now, I just want you to drive with me. Ask me any questions. You are free to stop me at any time and I will answer the questions. And anywhere you feel you're confused, please just give me. No question is senseless. No question is not to be asked. You can, it's better you ask it now than ask it while you're on the field. So welcome on board, everyone. And as I said, I wish you all the best as we start the class. Um, so this is introduction to manual testing. I'm just going to give a brief overview of the background to manual testing. Just an explanation for you to understand what manual testing is and what are the things that contains manual testing. I'm just, before this, I'll take an example of your day-to-day activity, of how you do things. So let me give an example. If you've got a pen, just not out of reflex, you were told to get a pen, start writing something down. The first thing you want to do to that pen is that first, what do you think if you are told, get a pen and a paper? I want you to write something down. What are you going to check? Someone should just put that on the chat for me. The first thing you want to know is that pen working? So you just scribble and just check if that pen is working. What are you doing at that moment? It means you're trying to test if that pen is actually working before you start writing. Take, for example, if you want to maybe you want to have your bath, you want to prepare your water. The first thing you need to check, hot and cold water. You want to know the temperature. You put your hand inside the water. Is this okay for me? That's a form of testing. You're only checking. Is this water warm? Do I want it hot? How is it going to feel on my body? That's part of testing. Again, you want to eat or you are cooking. For we ladies and the guys too that cook. Now, when you are maybe you're cooking now, you put salt. You want to test the food if it's actually tasty, or maybe you need more salt. You need to put um, what level is it? Do I need more or less, or is that okay? You take a spoon, take out of the food, taste it, and you see, is the salt okay? What you're trying to do is that you're testing if the salt is actually okay. So also take for instance, you are um you're boiling rice, you want to cook rice, and you put rice in the pot. At a certain stage, you want to be sure that the rice is boiled. You need to test if it's either soft or it's still hard or it's just the way you want it. So those are form of testing in our day-to-day activity. When you wake up in the morning, the first thing you do, you stretch. You stretch your hand, you stretch your leg. What you're trying to do is mainly testing. So at everything we do, there's form of testing. Give an example again. You go to a mobile phone shop and you get there. You want to you want to buy a phone. The thing you're trying to do is to check, is this phone actually what I want? That's another form of testing. You want to check if the mobile phone is working as expected and that. So I'll just go to the background. Let me give an example. I use an example of a new car here. If you want to buy a new car, the first thing is to know, oh, what kind of car do I want to buy? Okay, I want to buy a BMW. So you know the model that you want to buy. You go to a BMW showroom. When you get to the showroom, your expectation of a car, we know. We know everybody knows there's nothing different about the car. It's just features, functionality. Cars will still have their four wheels, some have three wheels. So it depends on what you want to buy. So you want a four wheel, mainly like a five wheel, including the extra. So if you're talking about that, you want to have your steering on it, you want to have the windscreen. There are certain features that you want in the car. Now you get to the showroom, you get to BMW showroom. You say, oh no, I want to buy this car. What you want to get in the car is, oh, does it have the four wheel? You are checking, does it have a windscreen? Is the door there? Is the arm there? All these are things that you check. The first thing most people check is, let me start the engine and listen. How does the engine work? How does it sound? That is form of testing. You check all other components, all other features. You look at the manuals that is on the car. What are the new things there? What do I need to understand? All these are form of testing in different phases. For instance, before COVID-19, during this pandemic, we've seen different testing phases. You see, we went through the trial stage before it was actually put out for every one of us to use. So certain things has to be done. Certain trials, certain tests has to be carried out before you can say, oh, this thing is working as expected. That is what we call software testing. That is what we call manual testing. That is so it depends on every area you're working. You get a form of testing. So that is so that's the form of testing they were talking about. And I can list several examples of testing. Anything you do, there's always a form of checks or for you to be able to execute or to use whatever you want to do. You want to the product or whatever thing you actually need to use. There's a form of testing. It's just like you go to the shop, you buy clothes, you try to fit it on. When you try to fit it on, is also a form of testing. So that's literally like a background of testing. There are several examples. So you can get it in the textbooks, several examples that you can look through for that. And that's the background check. So it's just a background of it for you to. Okay. So I'll move to mainly what are the topics that we intend to cover during manual testing. What are the things that we want to know? What are the things that we expected to know? The fundamentals of testing principles. If you're doing some things, there are some principles you need to follow. There are some code of conduct that you need to follow. There are processes. There are life cycles that you need to follow. There are levels that you need to follow. What are the types of testing that we are doing? We talk about static testing, dynamic testing, several phases of testing, which has to be incorporated. And most of these types of testing, most of this level are derived from English words, which are two words that with them you can easily understand. But now it's just to put it in practice. And when you're on the field, All these are the things that people want to hear when you're talking that, oh, I'm a tester. What are you testing in terms of functionality, in terms of the APIs? What types of testing are you carrying out? Is it static, dynamic, functional testing? All these are part of things that they want to hear when you are actually in the field. These are going to be taught in larger scale, more explicit when it comes to it's just an overview of this. So how to design test cases. These are major jobs the job that entails, that shows that yes, you are actually a tester. If I interview a tester that is coming on board, one of my interview questions, I always just give you a piece of paper. I'll just give you one feature. Can you just design some 10 scenarios for me? I know the key things I'm looking for. I know the key things that most people look for. And most of the time, when I also go for interviews, you're given sheet of paper. Oh, given this, sometimes you sit down on the computer and they tell you, design a script. They want you to, there are concepts that we follow, there are rules that we follow. All these are part of the things that we need to understand and have a deeper understanding of it. Most of the time, before you can do automation testing, if you're not vast in manual testing, I tell you, because no 100% automation, but manual testing, someone has to do a verification validation testing. How do you do this? This has to come in form of script, and that's where this design and the likes come in. So these are things that we are going to discuss in depth and fully about, give you an understanding. It's going to be hands on, purely hands on, because it's going to be an explanation of you seeing requirements, how you need to derive test cases from those requirements, how you need to design your script with user stories. All the different forms are the things that we're going to, is going to be purely hands on, but not, it's going to be in the internship. So I'm sure you're going to enjoy it. So let me go to different roles in software testing. What are the different roles that we have in software testing? Of course, it's just like you're doing, you're working in, and, you've got a role that you're working in. The software testing has different names, everyone call it. You could say it's manual tester, you're a manual tester. These roles, in quotes, we follow the same process. We do the same job. We have an understanding of the same thing. So you can be a quality assurance engineer, that's a QA engineer. You're also in software testing. You can be a UAT tester, and that is you can be a UAT tester, that's user acceptance testing. So in terms of you standing in, because standing in as a user using the application before this goes live. That is the job you are actually doing as a manual tester, as a software tester, as an automation tester. So you can be a test analyst, it's still the same role. You can be a manual tester, same career path, web tester, QA test analyst, functional tester, software tester, agile tester, automation system analyst. You can be a security tester. You can be a pen tester, that's penetration tester. You can be a performance tester. It could be API tester. So all these types of roles are what you can do. So we've got several roles that comprises of software testing. It's still the same thing that we all are achieving towards to. We all want to find the bug. We want to ensure those applications are working as expected before we start testing. So all these are the things that that's the career path, that's the roles that involves in testing. You'll be asking me, is this testing? Some of you will be saying, oh, you have been talking about testing. You're giving us example. What else can we understand? What are the roles? What are the type? How, is there money in testing? Because I know that everyone that is going on a career path, you want to know how lucrative it is in terms of finances. What are we looking for? So I'll tell you that you being on this platform, you listening to me, having to choose this career, I'll tell you, you're on the right path and you've got good ones on it. So I'm just giving you an example of the software tester skill. As I said initially, we are all testers. We are all testing. We are all going towards a particular goal. So it's either you are testing a software, you are testing an API, is automation. So it's different tools, but what we are all doing is we are all testing different roles, what how they are important, and this. So testing is the major thing. If you are given an application, you are given an application to test because you are going to be the first person to test it before it gets to public. You are going to be the one to give a sign off to say this work should go public. So if this is not properly tested, if now it gets outside there and it's the users, the public that is not telling you there is a bug, then there's something wrong with your job. So you need to find those errors. You need to find those bugs before it gets to the public. And that's why we've got different phases, how things are being deployed, how things are being tested, what at every phase. There are process and procedures for that, which we are going to look through. We are going to talk about it. We are going to discuss about it. Please do not forget any question. Please just pop it up on the chat. I also have my colleagues on ground, which I'm so certain they'll be answering your questions as we go along. So again, as I said, this is the most interesting part of it. What is the salary like? This is as at 2021 June. So if you look at it, this is what you can get. You can see you're talking about 50, even 50K. I can even, this is kind of still small, maybe due to the pandemic, but I can tell you honestly, we've got 180, 70. It depends on how you market yourself. It depends on how it is. But for the least, I'll tell you 50K, 45K, you're good to go. So that's the minimum that I always tell people that you can take. But to be honest, 70, 80, they pay good money because you are the one to say, now you can take this out. You are the gateway. You are the quality gateway. You are the person to attest that this product is fine. My signature is there. Hear me? I have tested this and I'm happy to put it out there. You all can deploy it. Simple. So your signature is there. If anything is there wrong with that product, it comes back to you. So that's why you need to test properly. That's what we are going to explain to you, how you're going to test, how you're going to capture the bugs. All these things are things, processes that you need to understand. You need to have in-depth knowledge of them. Then when you get to an interview, when you get to your work field, is is just going to be a workaround for you because questions like this are asked and we'll give interview questions talk to you as I'm talking. I can be asking you, telling you interview questions, little things like that. You familiarize yourself with it to have a better understanding of it. So as I said, that's the salary expectation. This is just minimum you can get. There is still the rank is high. So hopefully this should interest us. We can smile and know that yes, you're on the right path. So testing as a discipline is what I'm going to just say something quickly on. Just different tester, good software tester. What are you? What are the expectation for you to know that yes, you are a good software tester? You have great verbal and written communication. You've got passion, technical skills, analytical skills, attitude, and productivity. All these work hand in hand. You must be able to explain. both in written and verbally. This is what I've seen. This is what is happening. This is the bug that you have raised. Have you taken a snapshot? Can they see the link? Of course, if you put a picture that this is what you're getting, nobody can fight it because it's whatever you put in the picture. You can't form a picture. So you can just try and you must have passion. If you want to do anything in life, you must have the passion for it. If you don't have the passion, then you can't. We talk about the technical skills, and that's why you're here. You are learning manual testing first, then you go to automation testing. These are processes, these are levels that you must. The background, the foundation is where you are. This is the major beginning for you to understand that this is the career path I'm going to. Honestly, I'll tell you, you really have a fantastic time with us. And I'm very certain everything you're going to get good understanding. It's fully hands-on. And I'll tell you, you enjoy your time. Analytical skill, attitude, and the like. So the objective, what is testing, how is testing done, all these are the objectives of what we intend to go through in the manual testing phase. So I'll just dive in quickly into um, testing. Please, any question? Any question? Please just pop it on the chat for me, please. Is there any specific kind of writing? Okay, I think I'll just answer some questions here. So you said regarding written communication, is there any specific kind of writing test cases or script and report? Yeah, there are processes, there are ways that we write test cases, how we write the script, and also the report. So um, that's what that's what you're going to be trained on, as you have said, Rose. So just answering your question is there are specific ways because if I tell you write test cases and you don't give me what I want in that test cases, I will know that yes, the person doesn't know his or her job. But when you and write a test case and you put some things there, you don't need to finish it when you're giving it in an interview. I've gone to an interview where I was given a paper, just 4 lines, 4 lines. But by the time she saw my heading, all the headings, everything I put down, they didn't bother. They just said, give it to me. Before I got down, they've called me, start the job. So I said, I didn't even write up to 4 lines. The 4 lines, short lines. So, but she's seen the way I've organized my work. And that is the thing that you need in terms of designing your test cases, your script, and also reporting. So these are things that you need to know. Okay. So what is testing? This is an activity that is performed to demonstrate that something is working as expected. So as I said, if you get to a mobile phone shop and you have looked at the phone and it's not switching on, you try to look at it, oh, it can't switch on, then that is not working, is not working. So if it's not working, that's the reason you are going to know that yes, this phone you are testing it is not working. So these are experience, these are the bugs that we need to raise when we are actually on the field. Now, when you get to the mobile phone, you check it. Oh, yes, I can log in. I can see some features. These are the new things as expected. Yes, it's working as expected. If it's not working, then it's an error, it's a bug, it's a failure. So those are the things that you need to know about what testing is. So you might be asking, is testing for you? Let's see. It's not rocket science, but let's just see. You'll know if it's for you, which I'm sure is for every one of us here, because we do it on a day-to-day activity. So Who can test? Anybody can test. It's not rocket science. What can be tested? Hardware and software can be tested. And what are hardware? They're physical device, something you can see, you can touch. Take, for example, a laptop is an hardware. Then software, something that you cannot touch or see. Take, for instance, internet browser, your games, you can't see it. You can't see what's inside. So you can be asked that, oh, in an interview, what do you think, what can be tested? Hardware, software. Give example. Those are the things you give. Laptop hardware, software, internet browser, games, all these are things that can. So there are different references that we recommend when it comes to there are different things you can use out there. A lot of materials. We use Guru 99, use Logic, Tutorial Point, W3 Schools. There are a lot of references that you can actually look out there. And also, we have sure the admin has soft copy of the textbook, and you can also buy the textbook online on Amazon. So it gives you an overview of the whole thing we are testing, what's the whole process of testing, and what your expectations are when it comes to what you're expecting to see when it comes to testing. So references. So software testing. So what is software testing? It's an activity that is executed to demonstrate that a software is either a program, is either a system, a product, a web application, mobile application is working as expected. So this is what I've been saying all through, is just to ensure that whatever application you're doing, your program, systems, products, they are working as expected. That is the aim of a tester. That is your job as a tester. That is your job as a manual tester, as a QA quality assurance tester, as a software engineer, as a performance tester, as an agile tester. Your aim is to ensure that whatever application, whatever product you're working is working as expected. Testing is not complex. It's not difficult to implement, execute, and practice. Is a discipline. So software is a discipline. It's a job. It's a role. It's a name. Just like the QA test analyst. So how can a software be tested? It can be tested manually or automatically. Manually, which you're here in the class, we are doing manual testing. We are testing without any tools. So, but we are going to design our script. We are going to look at it and have a critical thinking that, oh, how is this script going to run? So when I mean a script, you're talking about you looking at, please, and also please just try and pay attention. There are some things I've been saying in terms of name, saying test script, manual testing, automation. All these are part of testing jargon that we say, just for them to know that yes, you actually know, you're on the field, you understand what you're doing. All these are the things that you have to talk about when you're actually um, conversing or having an interview. These are things that you mention frequently. So you're executing your test case without any tool. So say for instance, I want to go to Google application. I want to um, search for anything. Just search for manual testing. When you go to the Google, you launch your Chrome and go to Google and you type manual testing. There are things that you want to do there. So those steps would have been written in your test cases. it's a step that you're going to follow. So those steps are the way you are going to explain it. So now you can be in an organization where they want you to your manual testing. They want a granularity of it. When I mean granularity of it, is that they want it as explicit as possible. Giving an example, I've tested an application that it has to do um, with medical, and the users are going to be doctors, nurses, carers. So the only thing these people, and um they don't use lab, they don't use computer daily. So you need to explain to them so that when they are reading each line, they have an understanding of it. So the first thing I'll say, right click on this page, go to this page, navigate to this page. So you can see that I'm just trying to tell them, hold your mouse this way. Oh, so that is what it means, that you have to make it every step has to be detailed. Now, there are some that you want an eye level. Just tell me what is the next thing to do. These are users that already know the application. So they want to know, given I have this, I'm already on the application, I'm, I'm an underwriter, I want to check XYZ data. These are go straight to the point. That is eye level. And there are some that are middle. I want mixture of both granularity and also eye level. So you have to be able to gauge those places. Now, anytime you write test cases, and if I write a test case and I give it to you, to anybody, the person should be able to understand whatever I've written. If I read another person's test case, I should be able to understand and execute the test cases. So that's the way this whole thing works about test cases. Everything is going to be explained to you in details, hands on, fully, and you will be able to. So you can be asked, how can the software be tested? Manually, we are in the class now, we are doing manual testing, talking about test cases. I'm not using any tool, but automation, you have to use a tool. That's where you can use different programming language, different tools, different libraries to be able to do your automation testing. So it depends on the kind of programming language you want to choose, what you want to start testing with. So that's it. So software testing um, is the same thing I've explained initially. Why do we test? So what's the reason that we need to test? I'll give you an example. If you don't test, for example, you've gone to buy a car and you don't test that the brake is working as expected. If someone should carry that car out and the person gets out there with the car and the brake fails, what happens? Is it that the person dies, loss of life, or he gets injured? So what happens to the organization? It means the organization that actually developed the car is no. I won't be able. I won't recommend anybody to go there to to actually buy a car from them again, because if you've witnessed how the brake feel, so definitely you can't send someone there. So you're talking of loss of money, loss of time, loss of business, reputation, injury, and death. All these are key things that we look at, and the way you test different applications are kind of different. So if you were talking about a normal web application where you just want to search for a particular application, and you're talking about an application where you want a financial application where you're going to pay for the application. You don't want the way you're going to test it is different. There are different processes to it. Of course, we're talking about money now. So if people go there and I pay for my money, I want to, after shopping, and you finish buying everything over 100 quid, and at the long run, you can't pay. And it tells you, and everything is delivered to you without you paying. So how do they want to make the money? So all these are part of the things that you put in consideration when you're testing. And the risk of an application is different from it. The way you're going to test a vehicle is different from the way you're going to test an e-commerce application, is different from the way you're going to test a financial application. So all these have different phases. It has different expectation. It has different types of testing. It has different levels of testing. All this are put into consideration when you're testing. These three things I always tell you, this triangle, error, defect, failure, is a key one. You have to have great understanding of it. And um, just on eye level, error is human mistake. So when I mean human mistake, someone can make any mistake, maybe during documentation, during coding, requirement gathering. Anyone can make a mistake. So nobody can fall short to say, oh. So these mistakes that they make are that's what leads to error, and that error leads to defect, and the defect leads to a failure. So that's the face of it. So if you find a mistake, then that mistake, it will lead to a defect. For example, you found a mistake that, oh, this the mobile phone you are testing, you found that if you want to log in into, if you want to on the mobile phone, it's just switching off. It's not coming on. You can't charge it properly. There's no electricity in it. Nothing is working as so that mistake that you have found is what leads to a defect. And that defect is what leads to a failure. So if you found a defect is like is a bug. And when you find that bug, if that bug is not, if you found the bug, then can you say that the software is working as expected? No, it's not working as expected. So it's a failure. So that's the way these three work together. But high level is just it's just I will explain this better in in the class because um this is main questions that are being asked in interview. They'll tell you, give me explain what you understand by error, defect, failure triangle. So error, defect, failure. It follows each other. It's a linear sequence. So from error, it leads to a defect. A defect leads to a failure. I found a mistake. What is the mistake called? It's a bug. What is the bug called? Is the bug is called a failure because now that bug cannot make me do anything. It's not working as expected, which means that application, the mobile phone, has failed. So so these are examples of error. These are example of hierarchy that people can make error. It could be the BA, the customers, the architect. It could be the people. It could even be you. Maybe you're tired. It could be anyone that could do that. Defect, as I said, these are it's also called failure, consequences of defect. So all these are it. So keeping software under control. What does this mean? So you're keeping software under control. Some people want to know, oh, um, um, how is testing? What are the how can you keep it under control? You can't have been saying testing, testing, testing. You want to know when exactly can I stop testing? What time will I tell you that, oh, this application is working as expected? You can stop testing. So all these are things that you want to be sure that you understand when you're working on a with an application. So these key points are just exhaustive testing of complex system is not possible. So what are we saying? You can't tell me that. Give an example that you have tested the car and you know that if someone is driving that car at a very high speed, say like 110, 150, anything can happen and the person can just maybe fell and something happened to the car. So at that phase, you can't beat your chest to say, oh, I've tested everything. Even if this person drives a 150, when you know 150 is at risk, either nothing will happen to the car. Nobody can beat their chest to say that. Or you've tested this application. I'm so certain that you can't find any error there. It's impossible. It happens. I know because I've know some applications will work. Maybe is an existing one, different enhancement, upgrades have worked. Different things have worked. So there are lesson learned which has been done. But exhaustive testing of complex system, I can tell you can't beat your chest to say it's working as expected. It is not possible to run every possible test, simple or complex. All these are the things that is going to be explained to you. Why, how to run, how to prioritize your test. When you write your test script, there are priorities. Say, for instance, because most of the time when you're doing manual testing, I've got 200 test cases or 300 test cases to execute within a window of 1 week, 5 days. That's 5 working days, and you can only execute maybe 10 or 15 a day. In fact, 15 is not proper. It depends on if it's like data that you're talking about. You want to see how the data are behaving, data integrity, validation, verification. You need to go through those phases to ensure that these are working. These are the expectation. You need to review your mapping spec to ensure that is it exactly what they want to see? Is this what the business want to see? Is this what you are expecting in the requirement? As it work? So you have executed 15 and you got 200 test cases. Maybe two or three of you are the ones working on that. You are not expecting to finish that. Now, that is where priority comes in. There's a systematic way we do prioritization in terms of testing. So you prioritize your testing, you let these are my first phase, these are the phases I'm going to go through. If this works, then it's fine for me. Can we leave the cosmetics where maybe it's just something to do with in terms of maybe spellings, in terms of logo? Those could be the last later end. So there are systematic way of doing it. You can go for an interview and you'll be asked, how do you prioritize your work? That is another way. You have to put prioritization in it, and I will explain to you how to prioritize your work. When is testing enough? Testing and risk, testing and quality, deciding when enough is enough. So I'm taking testing. It's two words: testing, risk. When I'm testing, I'm looking at the risk. When I'm testing, I'm also looking at the quality. So then I can now say, oh, once I'm looking at the risk, I'm looking at the quality I'm testing, is everything as expected? Then I can decide to say, yes, enough is enough. So when these are phases that you need to go through. So what are the general principles of testing? So we have got 7 general principles of testing. You could be asked in an interview, how many testing principles do we have? We've got several, but the major ones are 7 testing principles. It goes hand in hand to just say, testing shows the presence of bug. Agreed, yes or no? Can someone type it in the chat for me, please? Testing shows the presence of bug. So what it means is that, does testing show the presence of bug? Can you give the title of the textbook, please? How do you know when to stop testing exactly? Yes, fantastic. Testing shows the presence of bugs. Sorry. Yeah. Okay, so before I continue, I'll just go to it. It says, I think Godwin is asking, can you kindly give the title of the textbook? Yes, I will. Admin will send the title of the textbook is Software Testing by Brian Amblin. He will send it to you on Telegram. Watch out. So I'll tell you before the end of the class or after the class, she'll send the name of the textbook on. So Rose, you're asking again, how do you know when to stop testing? Exactly. So that is when, if by the time we start designing our script, by the time we start looking at the requirements, by the time we start doing test cases, then when I ask you the question, you will answer it yourself. So then you will understand when to stop testing. So you can't say you have found 10 critical bugs or major bugs. If you found 10 major bugs, You can't stop testing. Those bugs have to be fixed. Now you fixed. You have done you've retested and you've done regression testing. You've still got 2 or 3 pending. Those 3 pending, how does it actually affect it? Now we'll weigh it. By the time you weigh it, how does it affect the application? How does it affect the product? Oh, if you've gotten a bug where it's easy for people to be able to hack the system, you can see everybody's card details is visible to everyone. If it's one of the critical bugs, yourself, will you be able to say, is testing? We can't stop testing by then. You have to. Now, you can't also test forever. Let me give you, let's say, example of testing for you've got a car. Don't forget that, like in the UK, where most of us are now, in the UK, we've got every year maybe 2 times, March and September, we've got 2 models of car that is going to come. The same car, but maybe just added features. So we've got one day that's going to come. So now you are given a car to test because you want to find the bug. You want to make sure that that car is working. You've been testing 2019 car. Since 2019 is now 2022. Who is going to buy the 2019? So that's when you have to know when testing is going to. So at that phase, before we say we want to stop testing, it's not going to be, it's going to be one, a decision from your side. And also you need to be able to back it with a report. And also give it to the business, to project manager, and also stakeholders involved to give a sign of this is the reason I can't put my feet down to say we have to stop testing. But if you wish to, these are the bugs I find. These are things that is critical. When you analyze it to them, they go back to sit down and think, which is true. We can't go forward, then we still continue. They fix those bugs. And once things are done, regression testing and everything, then we can say we are good to go with that. So that's it about that. So as I was saying, general principle of testing. So I'll say testing shows the presence of bug. Someone answered yes, thank you. That's fantastic. Exhaustive testing is impossible. Yes, you can't beat your chest to see. Early testing. This is where we are is kind of what you have to know now. Early testing, because early testing is what most organizations are doing now. Everyone wants to catch the bug earlier. The earlier you get a bug, the easier for you to fix it, and the less expensive it is than for you to get it at a later age, where all development, resources, time, money has gone down. So you now have to start from the beginning again. So the earlier you start testing, the better for everyone, for both the testers, the organization, the business, and everyone in general. So defect cluttering. So um, the pesticides paradox. All these are there are different explanations, which I'll go through them also later on because we've got limited time and I've got quite a lot to just give you an overview of. Testing is context dependent, absence of error, fallacy. Yeah. So these are the 7 general principles. So remember, testing shows the presence of bug. Exhaustive testing is impossible. Early testing, defect clustering, the pesticide paradox. Testing is context dependent, absence of error, fallacy. So quick question just to know if you're following me. How many how many numbers are the general principles? General testing principles?
7.
7. Fantastic. Thank you. Thank you. BC, Godwin, thank you. Buki, thank you. So what thank you, Saya. Yeah, so what's Miami, thank you. Thank you. Yeah, 7, 7. Good. Good. So I've got good students here. Yeah, fantastic. So let me ask you a question again. what what are the difference for just an explanation? What is the meaning of error, defect, and failure? Just anyone you remember, just pop it on the chat. Error. Anyone for error? Error is what? Fantastic, Michael. Error is human mistake.
Mistake,
Thank
yeah.
you. Error, correct, Rose. 2, defect. Error could be human mistake. Fantastic, Olusegun, yeah. Error could be, so what is defect? Defect is what? Defect is what? Correct, is a bug. Error leads to defect, Michael. Thank you. Eric, it's a bug. Fantastic. Error leads, yeah, correct. So what is failure? Yes, defects are bug resulting from error. Yes, error, that's Rose. Yeah, Godwin, thank you. Error leads to defect. Failure. Yes, thank you. Adetunji, thank you, Simi. Fantastic. So, what type of testing? How can testing be done? Don't forget, how can testing be done too? It's true that we said you are in the class of 1 now.
Yeah. Manual and automation.
Fantastic. Thank you so much. Thank you. Yes. Oh, thank you. Of course. Yes. Man, absolutely. Oh, in fact, you're already there. Oh, so we are getting there. Fantastic. Yeah. Good. 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 Thank you, everyone. So now I'm happy you're all following. So the next phase we are going to is fundamental test process. So now I'm going to use this one as a house. I'm going to be very quick with it. So take, for example, you want to build a house. There are stages you want to do when you want to build.
Hello, please.
Yes.
Hello, sorry to cut you short. While you were explaining the 7 general principle of testing,
Mm-hmm.
I want you to share more light on the second aspect of it, please.
Is it the exhaustive testing is impossible?
Exactly. What
I
does
know.
that sentence mean?
Okay. I so the reason why exhaustive testing is impossible. So as I said initially, I use let me not use let me use an application now. I'll use maybe if you've used, I don't know if you're familiar maybe with gift rate or Blue Sky. Let's use Blue Sky as an application. So if you keep testing Blue Sky from now till tomorrow, maybe you keep going, having different phases, different testing processes have gone down it. It doesn't mean that that application is not going to fail. Don't get me wrong. Don't get it wrong. It doesn't mean it's not going to fail. So the reason why we're saying exhaustive testing, why is believed that is impossible, is that you can't finish testing everything. It's impossible. You can't. You when I mean you can't finish testing everything, there is something you all are going to miss, and that is why we say box sleeps. It's not meant to be, but you would have done all your process, and that is where it comes to you backing yourself up. And this is the reason that you have the stage in front of me. So you can't say that I've tested Blue Sky. Now you asked the question, you said I should you if I give you Blue Sky to test from now till maybe 5 days, and you finish testing and tell me that, oh, this application is not going to fail. I can open that application and break that application. It will fail. Now, you might not test the volume and stress level of it in terms of the usage of the application. So now what happens if 1 million people uses it at once, at the same time, and it crashes? But you said you've tested it. That is an example of you not saying that exhaustive testing. Now, let me give you an example again. Is that you can you can say, oh, I finished, like let's use aircraft as another mean. Does it mean that because we know this air, aircraft has been tested properly, it doesn't mean that if people fly it, it might not fall off. No. So it's impossible for you to say, I have finished testing. I can give you the absolute fact that this is, there's no bug, there's no error. Nobody is going to believe you because there's no way you can say you finished testing. You're going to, because when I can give you several applications. Let's Let me give you a bank application just for you to know. There's a particular bank, a popular one that if I mention, you know. But when you're using the application, most especially on mobile, it moves. Once you if you click and it opens for you to enter your username and password, it moves away from there. It tells you continue to the next page. Nothing, you've not entered anything. So you have to go back to the application to do it. A lot of people have raised that bug in this UK. People have raised the bug. I've seen some bugs too in that same application. A popular bank, I can give you two of them. So don't forget, it's not that some people did not test that application. They did. But those things are things that you're not you it might slip. That of course, and you might even have tested it, but maybe just working in your environment and not that. So these are the reason why we say it's impossible for you to see exhaustive testing. And I'll give you more examples. I've got a table of example for that because I know that's always a question once you are doing manual testing. That question is always coming. And good for asking that, but I'll shed more light again. Attention. There is never going to be a bug-free application. Absolutely. Eric, I also want to explain the absence of error is a fallacy. That's just, that's what I've just explained. Absence of error. When you say, that's what I said, if you say there is no error in, there's no error in the application that you have tested, it's fine. What's it called? It's a fallacy because you know, is it true? It's not, because there's no how you can say that the application, even a live application, as in now, is got bugs in it. So you work with those bugs, and that's where I told you about prioritization. Like I told you, I said when you go to that application, the current one I'm saying, I'm using the application is on my own. When you open the bank and you go there, it's swing. It's not, it is not a critical bug. Neither is it a major bug. It's is a known bug, which I'm sure they know. But as long as I can't put my details there, nobody can put my details, nobody can see it. What do you think? They'll let it go. Then they'll look for a way to fix it. All these are JavaScript, Angular JS. Those are the things that are going to fix all these things. So they know what they're going to do to fix it. So they will still keep working on it to fix it. Because if they're saying, oh, let's wait for us to fix this one. So when exactly will these people use the application? We the users that are waiting to use this application. So that's the reason why. So that's the essence. So you said, Rose, testing is also affected by business knowledge. Yes, if my understanding is business knowledge, you mean the stakeholders. So whatever you're testing, that's why you've got a requirement, you've got expectation, you would have been in the kickoff meeting, getting an understanding. So yes, so whatever the business wants, because that's the people you are testing, but you have a say. You as a tester, is your name that is going to be the rubber stamp on whatever you have done. That's why you're going to have a report. You are going to have a test completion report to say, I have tested XYZ. These are my findings. I wrote, I designed 200 test cases, executed them, have this failure, have this percentage pass, have that pass. So these are things that we are going to go through. So let's just go through them. Um, if you still, I'm still going to give you more explanation on that, but we'll go back to the seven principles or the general testing principles is the major thing, and I'm going to still explain that in full. That's going to be in the internship. Each of those principles has a step, it has a process, it has an explanation. Interesting ones. So you get to know it. So let me just give you an overview of this. Test planning and control. So you are designing a house, you've got the foundation, you want to do the foundation, you want to plan. So when you do the foundation, how do you want the foundation to be? Is a solid foundation. It's going to carry a duplex. So the um, the developers know what exactly they want to do underneath. If it's just going to be a bungalow, oh, we don't need to do a solid dome. They know how that is going to be done. So it depends on what you want to do. So they need to plan first. They need to give understand. They need to analyze. They will look what design is going to fit this environment. You can't have maybe in the whole environment is all bungalow. Then you want to now build a 21-story building in that same place where there's nothing. For what reason? So those are the analysis they go through before that. So there's an implementation and execution stage. There's evaluating exit criteria and reporting. That is where the process of coming exit criteria, exit, stop, stop, exit criteria. So these are just words. And also we are going to have an entry criteria. Two things, exit criteria, entry criteria. Exit, stopping, entry, I'm starting. And those are things we are still going to discuss more on it in depth. All this are still going to be in the face, but it's just a journey for you to have an understanding. And reporting. Then test closure activities. What are the test closure activities? Like now, if I have 5 test cases, I've given it to you, and I was given 5 test cases to execute. Out of the 5 test cases, maybe 3 of them passed. So if maybe my manager or my test lead come to me to say, oh, Yemi, have you finished testing? Yes. What is the outcome of the test? I can't tell the manager or the lead that 3 passed, 2 failed. No, nobody wants to know how many. 60% of my test cases passed, 40% failed. Now, there is a yardstick that is being measured in every organization. Some will tell you 75% of it, with no critical bug, no major bug, no medium bug. Then if there's low and cosmetic, we are good to go, release the product. Some will say 80%, no major, no critical, no medium bug. There are different places yardstick when the test strategy, the test planning are put in place. So all these are things. So let me say an example again. If I give you 10 test cases and I tell you, and maybe 7 of them passed, what are you going to tell me if I tell you as a lead and I ask you, how many test cases passed? Can someone put it on the chat? What you're going to say to me if I tell you how many? Fantastic. Godwin, Bookie, thank you. So, no, it's not going to be 40 because now I've said it's 70 because I've said 10 test cases I've given you. 7 of them passed. So 7 passed. So just take it to 100. Yes, I got it too. I got it. Yeah, that's fine. Thank you, everyone. Yeah. No, I won't say 75%. The reason why I won't say 75% is because it's 10 of them. So if you put 10, 10, 10, that's 100%. We are aiming towards 100%. So for now, 70% passed. That's the one you have that is green. So that's it. So this process, this process is quite interesting. That this analysis and design, test cases come in, test planning and processes, test planning, test strategy, implementation, and execution phase. All the stages have several things that needs to be covered there. So psychology of testing, varieties of testing. So yeah, I'm just going to talk about the development life cycle. So we've got the software development life cycle, the different models, the pros and cons. All this will be explained more in depth. So these are software development life cycle. It's a life cycle. When I mean life cycle, you know the way we've got chicken. They start from the egg, they get hatched. That's a cycle. When they're hatched, they start growing. Before you know, they've grown to the other stage in 3, 4 weeks. By 6 weeks, 8 weeks, they are full grown eggs. So that's a cycle. So they start from there. And so it's a life cycle. So these are all the other ones. So we've got these other ones, Scrum, Kanban. But the major ones are waterfall, V module, iterative incremental development, which is called agile. I use the word agile. So also pronunciation of agile really matters. So agile, waterfall, V model, agile. So we're going to talk more about it. So if you look at, I just look at the diagram, and all this will be explained more in depth with it. I just want us to have an overview. So the reason for waterfall, if you look at the shape of that waterfall, sorry, if you look at this, it's coming down like a waterfall from the diagram. But this is different phases, requirement, design, development. So there's a story about this picture. There's an explanation about this picture. There's something happening in this phase, which you need to know. This model, this circle is a critical, there are things that we need to have a good understanding of. A better understanding, I'm going to break this down. Not today, but in the internship, explicit as possible. Each of this line, requirement, design, the phase, the reason for it, because all these ones, all this process, they do it and wait till the end. So by the time it gets to this place, that's when you can start. They bring it to the tester. Don't forget, all those processes have gone, no checks, no validation was done. By the time it gets here, if there's a bug, we go back, we go and start here. You see the money they've wasted, the time, requirement they've done, design, development. So that's the reason we advocated for early testing. So that's where early testing comes in. So if you look at the shape of this other one, it's a V shape. To every form of it, every testing, there is a phase. So every validation, there is a verification phase. Every validation, there is likewise, every verification, there's a validation phase. Most of the time, you are always asked in an interview. I'm very, very certain they ask you in an interview to ask you that what is the difference between verification and validation? Verification is you are given a product. Are you building the right product? Take an headset or a pen as an example. A pen. You want to be sure. You want to verify that is this product the actual pen they want? How do you want to know the actual pen? You've got requirement documents to go through, you've got the design to go through, you've got the key. All these things would have been part of a document, part of a phase before you get here, which I'm going to explain to you in depth. Now, what is verification? Verification is to show that really this pen that we have created, does it meet what the user is expecting? So the first one is verification. Is this the right pen that you are producing? The second one is validation. Validation, does it meet what the user wants to actually, the user's need? Does it meet it? So that's why we do verification and validation testing. I've looked at this data. Is this the expected data? That's what it is. So verification. Now, these are different. This is incremental and iterative, which is agile. So at this phase, agile is interesting. So if you do requirement, we first test from requirement go before going to analysis, design, coding. So if you do, first of all, if you develop the login section, you will test the login section at the finish. If that one is fine, you keep the code somewhere, you move to the next one, the search. Maybe search you want to, the development team are taking for that sprint. They'll develop the sprint. They'll set test. Once that is done for the sprint, we move to the next sprint until we get to the last iteration. So at each iteration, each circle, that's the way it is. So this is also incremental. So we start from definition of ready, backlog, sprint. We go to development, test, integration. We go back, sprint, then we go to delivery, then definition of done. This also is an interesting part. It's not something you could take the whole time to explain, but it's an interesting phase. This is how we work now. A full understanding of agile is fantastic because when you are pitching or your speech during an interview, your 5 minute speech during an interview gives you an overview of what to say. You do a sprint review, you do a sprint retrospective, you do your sprint planning. All these are embedded in this same circle, which is going to be explained to you. Sprint planning, a planning session, retrospective, lesson learned, what we need to do well. And we're talking about sprint review. We have developed XYZ. You can see it as a business. That is showcasing that in the sprint review, this is what we have done. That's the process. So this is a format. You're starting your own, you're starting it from here. So definition of ready, we are ready to start this. We're ready to start building this application. So all the requirements have been gathered. We are all ready to kick off. Now we've got a backlog. In the backlog, this is where we store everything that has to do in terms of requirements, the epic, the features. These are where it is stored. So now, sprint, this is the form where we are going to do it. Sprints are run either fortnightly, 2 weekly, or some do 4 weekly. Mostly, Agile Manifesto actually prefers a 2 weekly, just for us to check and have it. So if you look at the 12 prints and the Agile Manifestos, gives you major understanding of it. But now we are doing it on a testing phase. So after the sprint, once we pick it that, oh, for this sprint planning, logging is the main thing we are going to work. Everybody agrees. We estimate our times. We have different time types of estimation. You can use different, it could be t-shirt size, it could be any one. We have different one that is being used. So development. So the developers pick up the project, start developing, and once that is done, then they move it to the tester. And once the tester finish testing, takes it to integration. Integration intends linking everything up. Once integration is done, it goes down to delivery. Delivery, that's definition of done. That's the way the cycle goes. So I'll explain in full. So that's the same thing I've just done in that diagram. So types, test levels. So what are the testing levels we have? Unit testing, validated either by developer, and also sometimes we do it too. I do unit testing, I do peer review, I do unit testing too, but mostly it's done by devs just for them to have a proper testing that they've done it, because you're going to have great encounters with developer. They are your running mates, because once they do it, the quick questions that we always have is that it works in the developer's environment. Once it's deployed to test environment, forget it, it won't work. So they say, oh, it's working from my own end. So that's why we'll tell you how to take a snapshot, how you're going to send that to the right channel, and everyone knows. Integration testing done by the tester, system testing also by us, and acceptance testing by us as a user, and also users can also do that level. So these are the types of testing we are going to do. All this will be explained to you. Functional testing in terms of behavior, smoke, retesting. What is retesting? Two things. I said validation, verification. They are tricky words that you need to understand. Now, I'm telling you retesting and regression. What is retesting? Retesting. Now, I found a bug when I'm doing logging. Maybe a logging feature has been developed. And in the login, you need username and password. So maybe the username is meant to be yemi at test.com. That's my username. I give an example. Then my password is 1234. That's my password. So now I've registered and I want to log in. I tried to log in with the right login detail. The system crash, or it's telling me invalid password, or it's giving me wrong, some error popped up and told me you can't use this application. I take a screenshot, a snapshot, and I send it to the developer. He fixes that error for me. Not to forget, I'm only talking about username and password for login. Once he fixes the error, he tells me, Yemi, I've deployed the error. I go to my test environment. I do this. I repeat the same process I found initially. I use my username, Yemi at test.com, my password 1234, pam, and I enter. It logged in. It launched the application. Fantastic. I've retested the bug that the developer has done, has fixed. Now, what is regression? After I've retested that bug, there is every possibility, 99% possibility, that because he has fixed that bug, he must have touched some code which could actually affect all the previous things I've done, we've tested, talk about the set. So now you need to do a quick regression. The bug that the developer has fixed, I hope it didn't affect any of the other changes, whatever we have tested previously. That is what is called regression testing. So you're just running through it again. So that is regression testing. So we have got them testing. Testing verifies and validates that the test software application is bug free. These are the types of testing. So still types of testing, non-functional testing. So we're talking about performance testing, low stress and volume testing, security testing, usability testing, usability in terms of user compliance testing, is it compliant, sanity testing, just breezing through, ensuring structural testing. All these are types of testing. What is static testing? Static, stop. Just one seat. You are just standing there. Nothing is moving. That is static. So done when code is not executed, e.g. requirement review. So that's why I said there's it's going to be taught how, once you are given a requirement, I will tell you how to develop your manual test script that when you take it anywhere, when you develop it yourself, it sticks to you. When you go anywhere, you are going to save it. That's your own, that is for you. So that at any time you can go back to that and use that as an example to do wherever you go to, in terms of maybe you go to another organization, you start your new role. These are the things you are going to use. As I said, hands-on. So I'm sure I'm going to see most of you. So now, done in verification stage. That's where I've explained to you. Static testing, verification. Who can remember verification? If for you to be sure that we are actually testing the right product. So code is not dynamic. Dynamic is a moving thing, a continuous thing done in validation stage. Code is being executed. So that's the difference. Static is not being executed. Review. So there are types of review: informal walkthrough, technical review, inspection, all this. So I just jumped truly to test case and design. So I'm just going to explain to you what test cases are and the test condition and test cases and procedure. Then the test plan, test strategy, all will be done. How to design, full hands-on will be in the internship. So I'm just going to go on to this slide. We're about to finish. And please, if you have any question, I'm open to questions anytime. Let me just see if I've got any question here. That's what you just showed us, software development life cycle methodologies. Oh, they have also. So, Eric, yeah. So if you see, so I've said, I said software testing, manual testing. Are they the same thing? So these are methodologies. They are also the life cycles of it. So you're talking about the software development life cycles. That's the process. That's the life cycle I've shown you in the agile way. So there are the methodologies. So we've got different methodologies. Those are the 7, those are the different ones, the Scrum, Kanban, everything I shown. What is the life cycle? What is the development life cycle stage? That's where I've started. Definition of done, backlog, how it's been arched, going down to that stream. So that is the process. So let me take understanding the test case design. So test condition. 3 things that you need to note when you're talking about test cases. We talk about the test condition, we talk about the test cases, we talk about the test procedure specification, which is also known as the test script. So test condition, let me just give you, let's say, let me use an example to say, okay, you go to, maybe someone goes to the doctor and tells the doctor, oh, he's going there to complain about um, stomach ache. Or maybe let's do the first triage section when you phone a GP to say, I want to book an appointment. The first question is he or she is going to ask you is that, what exactly is wrong with you? Stomach ache. So stomach ache, all right. They take that condition down. Now you've been booked in. You're waiting to see the doctor. Not to forget, I said this is test condition. It's just a phase of it. So we want to know. So we know now that patient A is going in with stomach ache. So it's been recorded under his name to say stomach ache. So before he gets to the doctor, he would have opened to see, oh, patient A is coming in to come and meet me. He's got stomach condition. When before patient A gets there, they already process and procedure. The doctor would just get in once patient A, he would have set his test cases down. So the test condition, welcome patient A, you have stomach ache. First test case, the doctor will ask, when I press your stomach, is it aching you? That's one condition. If you move your body, is the stomach aching you? That's the second condition. If you drink water or you eat any food, is your stomach aching you? That's the third condition. Let's take those three conditions. Now, if you remember, I said that the patient went in there for stomachache. We stated these three conditions. If I touch this condition one, if the doctor touches it, does it hurt? No. If you move your body, patient A, does it hurt? No. Patient A, if you eat or drink, does it hurt? The third, he said, so those are the three conditions the doctor is going to ask patient A. So patient A comes in. The three conditions are set. So welcome patient A. You have stomachache. If I touch your stomach, is it hurting you? Patient A says, no, doctor. So now all the conditions, the test case that the doctor has written down is actually his expectation. This is the things wrong with, this is the answers I need from this person to be able to diagnose him. So he asks you, now I'm seeing the patient. He wants to see the actual thing that is wrong with it. So the actual result is there. When I touch the stomach, is it hurting you? He says no. So they puts it on that to validate it, to say, no, stomach not hurting. If you shake your body, does it hurt you? Oh, little. Then you put yes. Easier. If you drink water or you eat, is it hurting you? Ah, very well. Yes. And he puts it there. Because he has said no to one of these three conditions, then it doesn't meet the expected. So we count it as a failure. Once one condition is not met, then it's a failure because it's a process. That's the way he's expecting it to go. That's their own process. That's the way it's tabled. So now, don't forget, I've done test condition, my expected results, that's my test cases, and also the actual results. And now the status. What is the test status? Yeah, no, yes, yes. Everything is no. So it's a failure. So is it a pass or fail? Fail. So now with that, it shows that I've collected all the things that I need from patient A, So if I want to tender that, if that doctor wants to now diagnose to say this is it, the script is the whole of that thing because the patient has answered the question. So the script is the total execution because the doctor has asked the patient all his three questions and they've given him the answer. So that is just an overview of test case, test condition. I've just given you in a layman language, but in testing, it's more to do with it. This is an example of it. So this is a test cases. These are it. Test conditions tested, expected, the actual result. So now if everything is filled, then I've called it a script because it's passed, even if it's passed, if it's failed, this is a script. So this is the way you are going to design your own script by yourself. You do both granularity, you are going to do the eye level and also mixture of granularity and eye level. These are the ways, because I found out that it's taking a lot of time. Where I currently work is you they take you can't if you can't write a script, you'll be sent out manually. If you can't write it, you'll be you can't escape it because I've seen quite a lot. So you can't. You just have to. You just have to write it in a way people will understand it. I've been in a meeting where I was told to write high-level script. I wrote high-level script, understood by everybody. But you could have another person that I say, "Oh no, I don't understand it." Immediately, you don't get me unaware. I told her, "Okay, fine, you don't. This is granularity." "Oh no, he's too granular." I gave him, "This is the middle one." "Oh no, I don't want it." My boss had to ask her, "What exactly do you now want?" That is it. I've done my job. So this time around, I've given you three phases. It's there for you to see. At the long run, is the granularity they wanted. I give it to them. So they use that as a UAT checkpoint, the gateway. I used my other two. So meanwhile, I've done the job of three, four people. So you have to be prepared. So if you don't have an understanding of how to write it, people will tell you, "Oh no, you don't." But it gives you, because when I read the test case, you must be able to understand. If I give you this, you should be able to understand. That's the essence of script. So I'm not going to talk. So these are types of test case design: black box, white box testing. So I've got black box, white box. Just in terms of those names, I'll explain that in there. So categories of test design. So we've got experience-based technique, error guessing, exploratory testing. There are several experience-based. So what experience-based is that? I tell people there is nothing under the sun that is not been created. I've talked about cars. We have millions of cars, different types being created. I've talked about mobile phone. There are 1,001 mobile phones out there. The difference is just the features, little things that have changed. I've talked about pen. There are different means, different types of pen, different designs of pens. I've talked about aircraft. There are different designs of it. Talk about colors. So there are different things. So now, experience-based technique is your understanding. Now, I'm an experienced test analyst. I've tested an application before, so I have an understanding. Now I start another contract, another job, and in that job, I'm given a web application. Oh, I have an understanding of it, but they don't have any requirement. They don't have anything. I can use my experience from the previous ones, from other ones, from you can get your materials online. There are 1,001 materials online, and I'll use it to use it as experience based and start testing the new application, write the requirements, start doing it. Error guessing, in terms of the name, as a tester, you can use your testing skills to do some error guessing. What is exploratory testing? You are exploring the system. For instance, you want to try a new application. You want to log in into a new application. You are trying to play around with the application. You are exploring the system. So these are the categories of test kit design. Exploratory testing is always a necessity, and you must have good understanding of it. It's always an interview question. Exploratory testing, error-based testing. So, as I've said initially, test management, risk, and testing, all these are going to be explained in full. So we've got entry and exit criteria. We've got test plan and strategy. To tell you how to design a test plan, how to design a test strategy. You're going to do that. You have your template. So all this, you can use it by yourself. So risk and testing, not to forget, when enough is enough in testing, we said test and risk, test and quality, when to decide enough is enough. So it's coming back here again. Remember, when we were doing the fundamental principle, we were talking about five of them: planning, planning and design, analysis and design, execution and implementation, evaluating exit criteria and reporting. So if you have evaluating exit criteria and reporting, I said we have two of them, entry and exit. start and stop, when to start, when to stop, test plan and strategy. So these are things that we were going to talk about. So all these have different levels. So at this phase, these are there are a lot of things that we are going to still talk about. So test plan, how to write your test plan, how to design it, what are the things that you're expecting to see in your test plan, what are in scope, the resources, how the test approach is going to be done, your system test plan, your system tests and also the system test plan. Now we've got different places that this time around I'm going to do, I'm going to make sure that we've got three types of plans, which I'm going to explain in details. The test approach test plan, the system test plan, the seed test plan. Because I found out that in data organization, investment and banking, where they actually use majority data, validation, verification, these approaches have to be in place. So you need to know the test approach, which is more of an overview of it. It's a test plan on its own. Also, in the system test plan, it's just a navigation. This is the application. Can I access it? Is it giving me the right thing when I validate it from the back end, which is the database? Now I need an end to end of it. That's why I have a SIT test plan, system integration test. That's an end to end from point A to B to C, which is to the third party. So these are incorporated. I'm going to be talking about this, and I'm going to give you an overview of how to design this in the internship. I look forward to seeing you all.